We're going to move on and do some more with sequences. We're going to start graphing them. So the question for today is, how do you graph a sequence? For the most part, sequences are not too difficult to understand, and the graphs are also kind of the same, not too difficult. So first, we're going to do a recursive sequence. Basically, all we have to do is fill out a table. We're just going to graph them. So it's going to be a sequence where we have a table, and the table will always kind of be the same. Since this is your term number, it always goes 1, 2, 3, 4, 5, 6, and so on. So that will always be the left side of the table. And then from there on out, you just have to figure out what the numbers are in the sequence. So example 1 says, consider the sequence of the recursive formula a sub 1 equals -2, a sub n equals a sub n minus 1 plus 4 for integers n is greater than 1. One thing I want to point out about this one is that it did not use n is greater than or equal to 2. However, whenever you say for integers n is greater than 1 without the equal to, these two things are the same. So make sure you understand that. This one starts at 2 because equal to 2. This one says it has to strictly be bigger than 1, so this would also start at 2. So the first term they give us is always at the beginning, at the top line. That's -2. Put that in here. Then the rule is to add 4 to our previous term. Remember, this stands for previous term. So if we do that, it would be -2 plus 4, which is 2. Then we're going to keep adding 4. So 2 plus 4 is 6. Add 4, you get 10, 14, 18. Then we're going to plot the points. At 1, 2, 3, 4, 5, 6. Yeah, we can do that way. We'll go by ones here. At 1, it's the number -2. And since I think we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We only have 10 blocks. We'll go by 2s. So we'll say down here is -2. So at 1, it's -2. Put a dot. Then at 2, it's +2. Again, we're going to go by 2s. Put a dot. At 3, it's 6. So 2, 4, 6. Oops. 2, 4, 6 here. At 4, it's 10. So 2, 4, 6, 8. Here's 10. And at 5, it would be 14. 12, 14. And at 6, it's 18. Which should be right. It's near the top. Now, this is one of those graphs that because it is a sequence and the left-hand side is the term number, right? All of this are the terms. It would not make sense to have decimals here on the x values. There are no decimals on the x values here or on the x-axis. So the only inputs you have are whole numbers. And in this case, the only outputs you have are whole numbers. So the dots that we have are the only answers we have for the sequence. And that would be our answer. You do not connect the dots. So try to remember that. Do not connect the dots for a sequence. These graphs are considered, which we learned a while ago, the words between continuous, and which is not this one, and discrete. This is discrete. So just remember that you're not going to connect the dots for all of these. Example 2. A mathematician proposes a sequence to study properties of multiplication. Let S sub n be the nth term. The first two terms are 2 and 3. So they give us the first two terms. Beginning with the third term, each other term is found by multiplying the two previous terms. So we're going to write a recursive formula for the sequence. We have to do it ourselves. So we'll do a curly bracket. And it told us to use S sub n. So we'll do S sub 1 equals 2. This might be the first time we've seen this where they actually gave us the first two terms, and we have to determine the next term based on both previous terms. So the next one would be S sub 2. We have to identify that one since they gave us both these terms as 3. And then from here on out, S sub n would be equal to the two previous terms we have here multiplied together, right? Which would ultimately give us 6. So how do you write that? Well, we already know the previous term means S sub n minus 1. And we're going to multiply that by a more previous term. So this is the most previous. If we want to go back even further to get to the first term, we'd have to use S sub n minus 2. And don't forget the 4 integers. N is greater than, I'll just use the new one, greater than 1. So we'll go ahead and fill out the term, the table to find the first 5 terms, which they give us the first 2, so we'll need to have 3 more, really. So the first 2 terms would be 2, then 3. Oops, sorry, messed that up. We have to fill out our table on the left-hand side. The first 5, 1, 2, 3, 4, 5. Oh, goodness. And then the right-hand side is our terms. So the first term is 2. The second term is 3. Then the third term would be, remember, it's these two being multiplied together. So we're going to do 2 times 3 and get 6. And then to get the next term, it's to multiply the last 2 numbers. We're multiplying these 2 together. We're going to get 18. And then we do it one more time. 6 times 18. And that would give you 108. So doing these 2 now. And we'll try to put that on here and graph the first 5. Because this is such a much longer x-axis, we're going to go every other one would be 1 on the x-axis. So on the x-axis, this is actually our n values. So go 1, this will be 1 here. Every other 1, 2, 3, 4, 5, 6, 7. We only have to go up to 5 anyway. Then on here, I think we have enough. We need to get up to 108. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Let's just go by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We know we're going to have to get up to 108. So this would be 110. Okay, so we can plot the points now. So at 1, it's 2. So since this is 10, it's going to be kind of low down here. We'll put a little dot close here. At 2, it's just barely above that at 3. At 3, it's 6. So still not even up here. At 4, it's 18. So 10, 20 would be up here somewhere. At 5, it would be at 108. Up here. So very quickly with the sequence, it goes up incredibly fast if you multiply the previous 2 numbers. Even if we try to do the next one, it would be 108 times 18, which is 1944. So it's very, very, very high up there. And so that would be the graph. As you can tell, it's not always a straight line. The last one we had was more of a straight line. And that was pretty much the indication because we were adding 4 every single time. And so we kind of had like this straight or constant increase. Not having that this time. This one was more complicated and kind of crazy. So remember in chapter 1, we talked about a different type of formula that dealt with these sequences. With the ones we just did so far were called recursive. We also did one just last time, which was called explicit. We had a formula for that, explicit formula. So if you remember, instead of doing like we had like t of n, explicit means you do t sub n when you do formulas in these equations. So just as a reminder, explicit formula, that gives an expression for the nth term of a sequence in terms of n. And then as an example, again, it uses a subscript notation. It would be a sub n equals 4n minus 6, just to create one as an example. So we're also going to graph one of these. They don't always have to be recursive. Remember, recursive means it has the curly bracket and it shows you the 2 lines or more. We could also just do it with one equation like one of these. But really, it's no different than graphing one of these ones up here, except for the fact that you do not connect the dots. Like back here, we don't connect them, and similarly down here, we won't. Which is our last example. It says graph the explicit formula L sub n equals 97 minus 23n using the first 6 terms. And I gave us a little hint of going by tens on the y-axis. So for this one, I would just probably put in the calculator and bring up a table, or you could also type it in one by one. So I would just go ahead and do that. On my side, we would do 97 to get the first term. You're going to plug in 1. So 97 minus 23, 74. Then do it again. 97 minus 23 times 2, and that would be 51. Now, obviously, you don't have to actually plug in the new number every single time to get the next term, right? This is L sub 1, this is L sub 2. What we're really going to do is, if you notice the pattern, that we're just dropping 23 every time. So you could also just do 74 minus the 21, and you get your, I'm sorry, it's minus 23, and you would get your 51. So I can just keep doing that. I can take the 51 and minus the 23, and you get 28. Do it again. You get 5, negative 18, and negative 41. And then we'll graph them. Doesn't look like we can probably graph this one. We're only going to be able to go 10, 20, 30, 40 would be down here somewhere. So let's do the rest of them. So at 1, again, I'll just go by ones on this one. At 1, it's 74. So 10, 20, 30, 40, 50, 60, 70. So we're going to be right here. 74 would be right about there. At 2, it'd be 51, so right above it. At 3, it'd be 28, 10, 20, right below there. 4 would be 5. So this is 10 here. We'll go down about halfway. At 5, negative 18, so 10, 20, so negative 18 would be right about there. And 6, 10, 20, 30, 41 should be all the way down there somewhere. Down negative 40-ish. And again, we do not connect the dots. Make sure you're not doing that. And there's Team Huddle for you to try to do one with a recursive definition. There's a multiple choice problem to do, kind of reading the dots and see if you can figure out which one it is. There's another one that's a little bit more complicated. Whenever you go to do this one, just realize that the previous term shows up here. This is talking about putting in the current number of the term. So I'll go through this one real quick with you. Do like one or two more quick. So to start this one, you would do the previous term, which is 1, and then you would also plug in 1 for n. I'm sorry, 2 for n, whatever the n value you are plugging in. So for instance, if I was trying to find r sub 2, we know r sub 1 is 1. I'm trying to find r sub 2, that would be r sub 2 minus 1 plus 2 times 2 minus 1, because 2 would go into all the n's. So that'd be r sub 2 equals your previous term, 1, plus 2 times 2 minus 1. And that would give the answer of 4. And you could keep going from there. So you'd use 4 again in the previous term, but now you're doing plus 2 times 4 minus 1. So that would be 3 plus 8, so 11. And just go from there. And the last one I want to talk about is the number 4 for the huddle. It says, Forrest, a crime scene investigator, is called to investigate a missing persons case. Upon entering the person's apartment, he discovers hundreds of bugs crawling around. Suppose that the number of bugs increases by 20%. And I gave you a little hint, basically just tell you how to do it. You use 1.20 and multiply by the previous term. Every day, the apartment is left unoccupied. And that, on the first day the apartment was left unoccupied, there were about 10 bugs. So we're going to go ahead and do this as a recursive definition first. And we use b sub n for bugs on day n. So do a little curly bracket, do b sub n, b sub 1. They said there was 10 bugs the first day. And then from there, to get the next term, we would take our previous term, so b sub n equals b sub n minus 1, and we're going to multiply that by 1.2 to show it increasing by 20%. And again, we'll write for integers n is greater than 1. You're going to find the first 10 terms of sequence you found in part A of the sequence you found in part A and graph them. Okay, so we'll go ahead and do the first 10 terms. You do 10, then you multiply that by 1.2 every time. And you could do, you can round it if you need to. 12 times 1.2 is 14.4. Times 1.2 is 17.28. So we're going to do the first 10 here. You write them all out, and you would plot them over here. And that should be it for this lesson. Hopefully you were able to follow fine and are able to finish the rest of the notes, which only consists of one team mastery problem, finishing 4 here, finishing 3, and then doing multiple choice and 1 on your own. So it's really not that long. And we only have about 2 more lessons left with sequences, and we'll be done with it.